Today is July 30th, 2020. This is the Kubernetes SIG storage meeting. This meeting will be recorded and uploaded to YouTube. So let's first go to the 1.19 planning spreadsheet. The first one is CSI online offline resizing. Do we have a command here? Looks like he's not here. Okay. Okay, so does anyone know any update? Oh, hold on. Hey, can you keep an update on resize?
Hello, sorry, I joined just now.
Okay.
Okay, so we fixed a lot of issues, but we did not we fixed many of the outstanding issues, but we did not get the recovery from resize. PR merged. Tim had some concern about how or where that allocated resources field should sit. I think Saad had similar concerns. So I'm trying to talk to Tim and Jordan early in the next sprint and get a consensus so that we can merge it in 120 at least. Then the read write many fix was postponed because of refactoring change that Saad requested, but that's I think not super critical. And I'm planning to schedule a call next week to discuss if without the recovery from resize feature, if we can declare or we can move towards moving resizing to GA, because recovery from resize will be introduced as an alpha feature and it will be a while before that thing goes GA. So I think this is the same status I gave last time. So.
Oh, okay. All right. Thank you. Okay, next is support containerized CSI node plugins in Windows. Do we have anyone from the CSI Windows side to give an update? Okay, I believe it's working in progress. Snapshot fixing issues. Yeah, so we continue with the bug fixing. I think we want to cut a RC build once we get separate the API and client package out. So there are still some issues that we need to get resolved, and then there's also Andy and Xiangqian. I don't know if are they there? Are they here? So they are working on the webhook validation. So there was a design cap that we reviewed in yesterday's Deprecation work group meeting. So we hope to get that one done. And then that one actually would require some, there is some backward compatibility requirements for that because it's like a API change. So we will need to have do the thing like 2 phases. That's update from the snapshot side. Now recursive volume ownership. Do we have an update on this?
Yes, so I think this is the same update that as last time I gave.
Okay.
Me, Michelle, we talked on a call and we agreed upon how the new implementation will look like, and I'll update the cap for that implementation and try to get as many eyes on it as possible.
Okay, so this is targeting 1.20 to go beta, right? Is that right?
We are changing the way it works, so I think it will remain alpha, but
oh, okay.
Yeah, it will remain alpha most likely because
Secure Linux recursive mission handling. Can someone give an update?
No update.
No update? Okay. Same,
No
basically
update.
same as before?
Yes.
Okay.
It needs to be completely reworked, and I will try to get some kept as early as possible.
Okay. All right, thank you. File permission handling for Windows not started. Is it still not started? Okay, I assume this one is still no update. Not started. See anyone? Let's see deep chain here. Next one is file permission handling in projected service account volume. So that one's done. So I think we don't need to give an update here. CSI entry read-only handling. This one says not started. Is it still not started? It's Humble here. Sad, do you know anything about this particular one?
No updates as far as I'm aware.
Okay. Next one is issues related to assuming volumes are mount points. Okay, this one, do we have any update on this from Andy, Xing, Michelle? Okay, I'll just no update. Storage capacity tracking. Is Patrick here? Jan, do we still have any PRs pending in external provisioner for this feature?
I think so.
Oh, okay.
It hasn't been merged yet.
Is he, Patrick is on vacation, right? So, but okay.
Yes, it's still not merged. Work in progress.
Oh, okay. But we expect them to be done when we cut the next external provisioner, right?
Yes.
Okay.
That was the plan.
All right. Next one, PVC inline ephemeral volume. Does this one need any changes in external provisioner? Jan, do you know?
I think that feature is
it
done.
done?
Well, yeah.
Is this only entry changes? It doesn't need any.
I think so.
Okay.
Or
right.
At least if it needed any changes, they were merged in the external provisioner.
Okay. Thank you. Spreading over field domain, so that's mine. I don't have any update on this one yet. I worked this one together with the volume group. So this one I need to schedule a review meeting. And next one is CSI Autotree. Okay, so this one says done, move manifest driver finish done. Next one, move iSCSI driver. Autotree is this one. Does anyone know the status of this one? So Michelle is not on today, so it's no update. So those will probably still not started. CSI fiber channel and flex volume. It's probably the same. Okay, it says we'll move to deprecation T1.20. Okay, so I think it's probably the same from last time. And then move out GlassJFS provisioner. This is on the Humble. Is Humble here? Does anyone know the progress on this? Jan, do you know? You're the reviewer.
No,
Okay.
I don't know any progress.
Okay, so the next one. Next one is move out to NFS provisioner. So that's two, NFS provisioner and NFS client provisioner. Karen?
Yeah, I think on this one, the initial PR got merged last time and started to test it out locally, and I raised one more PR on this one to update the docs and all that. Taking the help from the community members who signed up for the migration also to review. Maybe once that review is done, after that I'll reach out to Jan or Michelle to merge it.
Okay, that's the first one or the second one? That's the NFS.
So for the that's the NFS, yes. For the NFS client provisioner, I have the initial PR that actually migrates. I also pulled in some of the changes that were done in the external repo after I worked out, commented on all the issues there and the PRs to take the help to move here. The initial PR is ready for review.
Okay.
Jan can take a look at it. And I will pull in the remaining PRs also here slowly once this is merged.
Okay, thank you. It was the deprecation of Kubernetes incubator external storage. Is there any update? Okay, so it looks like it's where we need to wait for NFS and cluster before we can do anything for this one. So it's probably the same.
I think the code is already migrated. Is it a good idea to go ahead and deprecate it so that at least we put up a notice there so we don't get new PRs there and they can be directly given into the new?
Yeah, but is everything moved out yet? I'm not sure about I'm not clear on the status. Right, the cluster, it says no updates. I'm not sure if cluster is out. Right.
Yeah, cluster, the initial code is already moved out. It's the automation of the build that is pending.
Okay. So we need to ask Michelle, and I didn't follow with this one. So are we ready to deprecate?
Yeah, I think that's fine. Go ahead and put the deprecation notice there.
Oh, okay.
It'll start serving as a reminder for folks that they should stop using this repo.
Yeah, was this code moved out before 1.18 was released, or has it happened since?
Okay.
That was a question.
Sure. Okay.
Sorry, could you repeat your question?
Was the NFS and the Gluster code moved out of the in tree and moved to CSI in 1.18, or has it happened since 1.18 was released?
So you're talking about the code that used to live, the external provisioners that used to live in this repo?
Correct, yes.
So those external repos are still in the process of being moved. I think Karen just gave an update on the NFS one. They were moved this quarter, which aligns with the 1.19 release.
Okay.
And then the CSI drivers are kind of standalone. They're not necessarily a direct replacement. If somebody was depending on these old provisioners, they can continue to use them.
Hey, John, I wonder if your question is actually asking about the in-tree driver.
Correct.
Yes,
that's right.
This one is we're talking about, there is a repo called Kubernetes incubator external storage. This is a different repo, not the in-tree repo. So the in-tree drivers are not moved yet.
Okay.
So, so the in-tree driver right now, only the cloud providers has been moved out. And then the next one, I think it's Ceph, I believe. I haven't heard about the cluster. I have not heard. Sad, have you heard anything about that, like from in-tree to
No,
CSI?
not yet, but we need to start thinking about that in the next couple of releases.
Okay.
Yeah, the reason I ask, and I'm sorry, I don't wish to belabor this, but I had one of my team look at this, and in 1.18, it appears that the in-tree provisioner is still available.
Yes, yeah, and they'll still be available in 1.19.
Ah, okay. That's somewhat unfortunate because we've got people who are documenting how to use this, and I would prefer not to do that. And they'll do that so long as it continues to exist in tree.
Yeah, the entry stuff is hard to get rid of because it's exposed through the Kubernetes API, and Kubernetes API has a very strict deprecation policy. We can't just pull it out.
Got it.
So even if we end up removing it, we need to keep the API and then actually divert the internal logic to CSI. So that's what we're doing for the cloud providers.
Okay, good. Thank you. I appreciate the clarification very much.
No problem.
Okay, thanks, Sad. Next one is volume snapshot namespace transfer. Do we have any update on this? No update then? Okay. Warninghouse. Yeah, so we have been making progress on Warninghouse. There are a few PRs to add tests, so I think those should be merged soon. And then there are a couple bug fixes that we need to make. I think we are on track. Next one is Object Storage API. There's Jeff here. Anyone else working on the Object Storage API here to give an update?
Yeah, so they did a review of the KEP last week. They're going to continue that this week. It'll be on this same Zoom right after this call. And they're going to likely go over the spec, the cozy spec, hoping to get that wrapped up either this meeting or next meeting. And once that's done, the KEP is approved, they're going to be unblocked for a prototype.
Thanks, Sad. And next one is CSI ephemeral volume beta. I believe there's no update on this. Yang, right? We didn't do anything on this one. CSI ephemeral volume beta, right?
No,
It's just no. Okay.
It's just waiting for the generic ephemeral volumes.
Okay. Right. Generic. Thank you. Next one is FS group support in CSI. So this one is done. Okay, I think. Okay, that's done. There's no more work. Good. vSphere CSI migration is yeah.
Apologies. One note about Rev 30. There is a small PR out to implement some of the nitpicks that were open before it was merged. That needs an API reviewer. I pinged Clayton, and I'm waiting on his reply. But it will be included in 119 as is.
Okay, so you will be backported?
No, it just needs to clean up some of the description and the API types. So there is a little bit of outstanding work, but the feature itself is included.
Okay, but the API, this changes I need API review, then that change will be there. It's not going to be a backport because it's API change, right? Okay.
Correct. That's my understanding.
All right. Sure. Thanks. vSphere CSI migration is Debian here. Okay, so the in-tree PR all merged, including docs. So there are still some issues that we are fixing in the driver repo. So and also doing more testing. And then I think we're going to have a meeting with the cloud provider side to decide when we can move to GA, when we can remove the in-tree driver. So I think there's a meeting coming up. Saturn, is it anything else on this for the CSI migration?
No, not as far as I'm aware. I think the next step is just a meeting to discuss next steps.
Mm-hmm. Okay, thanks. Azure CSI Migration. Do you have any update on this for Andy? Okay, great. And the next one, okay, that's crossed out. AWS CSI Migration, not started. Okay, I don't know if we have Matt here. Okay, no update. Openstack CSI Migration, also not started. John, do you have any update on this?
No, I don't. It
Okay.
is rather well documented in the OpenShift online documentation, although I'm
Okay.
not aware of anyone using it.
Okay, thank you. So, okay, yeah, so this one's is under Humble. So it looks like Humble is not here, so just put no update here. And then we have this immutable secrets and fig maps. That's done. Okay, so this one is done. Next one is PVC created by Steve said will not be auto removed. Do we have, I think KK was working on the, okay.
Yeah, I've raised a work in progress kept based on our internal discussions.
Okay.
So we'll go through some review and discussions on the KEP.
Okay, thank you. Can you add a link here?
Yes,
Okay.
I'll add a link.
Thank you. Wording extension for stateful set, so it's also KK, right?
Yep. So the KEP was raised. There were some comments from Ken, but Hemant and I are meeting up today to discuss the decrease in volume size, and we'll go from there.
Oh, okay. Thank you. Okay, so execution hook for application snapshot. So this one, I need to schedule another meeting to discuss with Signode. I do get some comments from Tim, so I need to update the proposal. Is that? So. And the last one is Kubernetes utos mount split into a new repo. Do we have an owner for this? Looks like we don't have an owner yet.
I think there is an owner. There was work started this quarter, but
oh, okay.
I believe it wasn't completed. Can you check the status from last time? I
Yeah.
think it should be.
Okay.
The mount details, right? This is Srini.
Yeah.
I
There you
want.
go.
Oh, okay. Srini, so should put this.
Yeah.
Maybe you can add your name. I'm not sure how to type.
Yeah, I will do that.
Okay.
And
so,
yeah, the first PR is out and it's still ready for review. It's blocked because of the 119 port freeze. So.
Okay. Thank you. All right. So, okay, that's all we have on the spreadsheet. We'll go back to here. We don't have any PRs listed here. We have a design review. So this is also from KK, dynamic performance attributes for Kubernetes storage. KK, you want to talk about this?
Yep.
Let me actually open this. Okay.
Yep. So this is a proposal that we are trying to raise for more community input. This work is currently involving Vaibhav, Andy, Alec, and me. So we want to introduce performance as one of the dynamic attributes into the Kubernetes storage. So for that, first, we'll go through some of the use cases. So if you could move to slide 2.
Yeah.
So basically, one of the use cases is where there is a relational database which is running with OLTP workload, but at the month end, the database will have to do some batched work, which requires more throughput from the database, which is mounted on a PVC. And the way that currently this would work is that we'll have to go back and recreate the PVC or do some kind of custom stuff to make this change in terms of the throughput happen. The proposal is that if we have this dynamic performance attribute setting, we could just modify this dynamically, and at the month end, the administrator could set this up so that things go at a higher throughput, and then bring it back down when it's required. It can also become part of the automation infrastructure of the whole user infrastructure that is around the Kubernetes cluster, wherein the system itself knows when to go up and when to bring down, and they could just use Kubernetes primitives to make this happen. There is another use case where gaming workloads are concerned, where there is like a distributed gaming workload scenario. But there are spikes at certain locations and no spikes at other locations. So this is another scenario where when the spikes happen, based on those spikes, the PVC could be tuned to increase the throughput, and we could throughput and IOPS, and we could get to a point where these customers, these users are served well as well. Another scenario is the dev test scenario, where there is like workload costs, which becomes higher when with higher throughput and IOPS, there could be like larger bills which would come for the user. So the idea here is that we could set restrictions around the quotas of these performance attributes, and thereby ensure that it doesn't do a cost overrun for the subscription bills and things like that. Can we go to the next slide?
Yeah.
So currently, Azure offers something called Ultra Storage, which has this capability that once the PVC is created, you can basically go and modify the underlying throughput and IOPS without any runtime changes required from the rest of the infrastructure. So Amazon also seems to be offering the same kind of feature, but we are not experts in Amazon, so would like some community input if there are folks listening into this conversation. Any other storage providers, if they are offering similar features, that'll be great to know as well. That's where the underlying storage understanding of what we have right now. So if you start looking at the current state, which is the next slide. So current state is that if a user has to provision these kind of attributes, what can be done is that the storage class parameters can be modified, can be created, can be added when the creation time. But once it's provisioned, this cannot be modified, and also it cannot be used for resource quotas as well, which lands us up in a very static kind of possibilities here regarding performance. So that's one of the trigger points of this proposal, that can we make something happen where there is this dynamic nature of throughput and IOPS, and potentially other performance parameters which we can anticipate and add to this infrastructure of Kubernetes. Can we go to the next one, please? So the goal is that there are at a high level, there are three main goals. One is that we want to be able to we want the user to be able to dynamically provision based on a performance attribute, so that there is like a PVC match which is made to the corresponding PV which has the required performance and IOPS. Then the ability to kind of modify these performance attributes at runtime, just like storage size currently happens. And then also this ability to kind of set resource quotas based on these performance attributes as well. So those are the high level goals of this proposal. Yeah, we can move to next slide. So one approach is that we make performance attributes a first-class citizen in the persistent volume. So here is an example which I put like to indicate how it would look like. So this would be very similar to what we have in terms of storage, but we would have these two additional parameters called throughput and IOPS, which would be set up in the request. And then when a PVC is either dynamically created, it would go and set this up to the underlying PV. So we would be changing the PV also to have these parameters. This would be actually just another resource list, which would be named performance, like, because current resource list is not generic and it's very specific to the capacity. So we would be needing to add one more resource list, which is like a performance resource list. Corresponding to that, we'll have to change the PVC status as well to represent the status of what the update happened, or current state of those current state of this these fields in the PV as well. Can we move to the next? Yep. So we'll have to add new resource types to the IOPS, and basically IOPS and throughput would be the new resource type. The same resource type can be used across other places where we are thinking about throughput and IOPS in general as well. We will also need CSI spec changes where create volume will have to accept these IOPS changes, and also we'll have to convert the current update volume call that is there to update the size, which is very specific to size update. We'll have to make it a little bit generic if possible to have a controller update volume kind of call. Or we could have a scenario where we have a separate call for the performance updates as well. So those are kind of the CSI spec changes. We will need some changes to the external provisioner to make sure that it passes to the create volume, and also changes to the volume matching logic that is there around matching the PVCs and the PV. So these are the anticipated changes that could be there if we kind of go ahead with this proposal. Yeah, please go ahead to the next one. Yeah. So another potential possibility here is that we could have modifiable options as parameters, or some other way in which we can have this update as well. But right now, this does not, the current infrastructure does not give us that ability. So we'll have to add this, make either the options dynamic and then add this as one of these options which would pass in through from the top level to the end provider code that is around. So that's one other option that is around. So this we are looking for feedback and inputs from everybody on this.
So for the second option, instead of saying we are only modifying the IOPS, I'm thinking that maybe we could also think about modify or change a storage class to a different storage class or something. Then that would include that will handle not just this performance attributes, but also other attributes defined in the storage class as well. That's just a thought.
So I think in general, what we want to do is after a volume is provisioned, it should act independently of the storage class as much as possible. We probably didn't enforce this as strictly as we should in our initial design. But the idea is that once a volume is provisioned, everything that you need to know about that volume should be in that PV object. And you shouldn't have to go and look at the storage class object to figure out what to do with it. And modifications to the storage class object shouldn't really affect the already provisioned PV objects. But that said, I think I completely understand this use case. My recommendation would be, one seems very heavyweight. I'm not sure if we're going to be able to design an API that's going to work for everyone in terms of representing IOPS and throughput, but it's on the kind of right direction. But I think a third option here to consider is, and it's something that can be implemented more quickly for an individual storage provider, is when you provision your PV, automatically create a config map with the IOPS information in there in the user's namespace, or have the user create that config map and then reference it in the PV object when it's provisioned. You can think of this kind of like, if you're familiar with how secrets are done in CSI, your CSI storage class can reference a secret. It could be a fixed secret, or it could be a dynamic name that is generated based on the PVC name, things like that. And so you can imagine a config map that you reference with information about IOPS. And then there's a pointer to that in the PV object. And then you basically just look into that object. You would have to have your own controller to monitor the config maps and do the relevant updates. But it would allow you to do effectively this dynamic IOPS behavior without any changes to the core. Does that make sense?
Yes, one quick question there is that how do we handle this quarter related stuff in that in that context, and also how do we kind of match the PVC kind of scenario if we have to match it using performance aspects? Like, is there a way to leverage this to make those two happen?
What do you mean by match PVPVC?
So if a PV exists which has a certain performance characteristics, and a customer comes up with a PVC saying that this is what we need to match, how do we work out with the config map approach?
Right. So you're thinking about like the pre-provisioned case, like someone already has a. So I think that depends on how you're going to generate the config map name.
Okay.
If it's some deterministic way of generating it, then you could, presumably manually create that config map object at a later point. And if it exists, then whatever controller is monitoring for it can say, oh, yep, I see this now exists. I'm going to start using its value. If the value doesn't match what I expect, I'll go ahead and issue a call to change that.
This is Chris. I think that one is already solvable with the storage class as it is today, right? Like you would just associate the different performance characteristics of your pre-provisioned volumes with the different classes of storage, right?
I'm not sure that happens the way it is. Currently, the storage size is mapped, but I'm not sure about the other one. Maybe there are folks who
I guess like if it has to do with the volume being provisioned to support a characteristic of performance, then you could easily just provision those volumes and associate them with different storage classes. Like
actually, I mean, instead of updating the storage class object, you just update the PV object to point to the config map that you want. So you can imagine, I have a pre-provisioned volume, and I want to introduce this and take advantage of this dynamic IOPS ability. So normally what I would do is create a PV object, create a PVC object, have them bind together. So for this case, in addition to that, I'll create a config map, and in my PV object, I'll point back to that config map.
I feel like cake. Sorry. So I agree with Chris. I think cake is a pre-provision case. He asking about matching between PVC and PV. Then let's say you have a volume available with certain parameters, so you create storage class with some name, let's say performance A storage class, and associate with that storage class. And then PVC also requests that storage class. Then PVC and PV can match.
I see. So this is not I have one disk that I want to bind. It is I have an arbitrary request. I want to be able to bind to a pool of available disks.
I think so. Right?
Okay. Okay, then that makes sense. Yeah, that would work.
And then on the dynamic, I do have a comment on the config map. Personally, I don't like the idea of using objects that are also user configurable from a namespace. Like there's no control knobs then. So if a user has access to his or her or their namespace, then they will likely be able to edit their own config maps in their namespace, right? And you now can't like protect what someone can configure in those parameters. Whereas if it was a different object, you know, CRD or whatever, that was like volume performance parameters object, I don't know what you would call it, you could then lock access to said object versus you can't if it's a standard object config map.
Yeah, you could do that. You could create a non-namespace CRD, or another option is
or
tuck
even
it into
a
another
namespace
namespace.
CRD.
Yeah.
And you just don't, even if it's namespace, you can still prevent access, right? Because you just wouldn't create role bindings that give them permissions to edit
to
it.
that namespace. Yeah, and in that case, it doesn't have to be a CRD. You could leave it as a config map and just put the config map in a namespace the user doesn't have access to.
Oh yeah, that is actually also quite possible. That's a good point. You could put it in the where you provision your controller.
Yep.
I was just thinking out loud here. How about another approach where, let's say, there are two storage classes. One is low performance, and another storage class which is high performance. And the DevOps persona, the namespace user, would go ahead and create a PVC with a low performance storage class. And whenever the user needs a higher throughput, you just update your PVC with the storage class, with the new storage class. That would basically have a callback into a controller update, kind of a CSI API or something, and cloud provider can go ahead and apply the newer storage SLAs. Is there any reservations around going down this route?
Yeah, I think the idea of changing the mapping of a PVC to a storage class after it's provisioned is odd. Ideally, what we want is a storage class is a template for provision time. After provision time, your PVC and PV should effectively operate independently of that storage class. And I can kind of see this logic of like, oh, if I change the storage class, maybe, you know, like today, if we change the size of the PVC, we force a resize. If you change the storage class name, it should change performance characteristics or other characteristics. But given the amount of characteristics that can be tuned by a storage class, it just seems very strange to me, because you could put in things like access mode in there, and yeah,
or like encrypted versus not encrypted, like things that aren't changeable after the fact.
Yep.
But I think those would be implemented by the drivers, and the drivers would know, you know, what can be handled, what cannot be handled, right? So you could have some method to validate, you know, what are supported, what are not supported. Because before you really go and do an update a storage class, you can first run this validation to see if this is a supported type of change.
Right.
And
so, sorry to cut you off. So I just want to speak about some of the experience I've had with the storage vendors. Most of the storage vendors actually support dynamically changing the performance characteristics or even the availability characteristics of a storage object. So having a mechanism like this in CSI will be very useful. That's what I think, at least, but I don't know if it applies for like public cloud vendors.
So like, for example, in Cinder, we do have a Retype, which is change the volume type, which is very similar to change a storage class. So
so if we go down the config map approach or the CRD approach, where PVC points to one of these objects, would we cover these other scenarios as well, you know, which includes performance? Like Cinder case, would it cover that case where config map has an entry for this?
I think you could make that work, right? So that config map, you define what is in the config map.
Yep.
That would work, I think.
Also, did I hear this would be a config map per PVC? I think the way I would think this would work best is if you had a config, if you created a handful of config maps for a name of a performance characteristic, take the gold, silver, bronze, whatever you want to call it for performance tiers. And then it's up to the storage provisioner to manage in the storage provisioning namespace, potentially a series of config maps that represent these options. And then a user might be able to modify their PVC request.storage performance, whatever class. And that would then allow the storage provisioner to go ahead and modify those configurations on the fly.
So what I was imagining was kind of leave it up to the cluster administrator to design, to figure out how fine-grained they want to be. Very, very similar to the way that we do CSI secrets today, where you could say that it's going to be different per volume if you want, or it could be fixed to a subset.
Yeah, I was just concerned on the object quantity barriers. I mean, in our environments, we're approaching over 10,000 PVs.
Yep.
Yeah,
if that's a concern at all, then the cluster administrator can decide we're going to have a fixed set that the user has to select from.
Yeah, I think that makes more sense. This config map approach would basically mean we are giving control to the namespace user to set whatever he wants, and maybe the cluster admin may not want to give that flexibility.
Right. So the cluster administrator, like whatever design we come up with, has to leave the cluster administrator in charge of whether they want to give the flexibility to the user or kind of hide that away and let the cluster admin decide.
Right. Yeah, I mean, then going back to the thing that I was saying, which is like cluster administrator can define like low performance storage class, high performance storage class, and the user could dynamically change the PVC storage class depending on their needs.
So instead of the storage class object, like a good quick way of doing this again is like config map, right? So you could have a user visible config map object inside there. You could let them select, high, medium, low, whatever, and then your controller can operate off of that.
When you say your controller, are you thinking of like this is going to be outside CSI?
Yes. Right. You're going to need some sort of additional controller that'll have to reconcile these config maps to actually go and issue the commands to change the underlying IOPS. So it'll have to be a new additional controller.
So I will say that I implement this already today, and advice I would give is instead of doing like on the fly updates, you would tell your end users to change an annotation or whatnot, that if you want to use an annotation because it's probably easiest, or a label. And then you would just tell the user to delete their pods that are currently using the current performance tier. And then when they get rescheduled and they get remounted, you would have your attached logic go ahead and fire up the proper performance tier. So then you don't have to create a whole new loop for it.
Yeah, I think the only drawback there is you have to modify the PVC object and put annotations on it, which are specific to a given storage provider. Generally, we want to try and avoid that.
Well, I guess how else would a user imply that they want high performance for a PVC versus not?
I mean, so if we implemented this storage class proposal, then it would be very explicit, right? It would be the storage, one of the parameters in the storage class says, use this config map for performance tuning. And then the existence of that storage class will block provisioning.
But see, then that wouldn't be changeable, right? Because I thought like the main desire here was I have these series of 1 terabyte volumes that I want to be low performance most of the time, but then I want to convert them to be high performance for a period of time.
Right. So when you provision, it looks at the storage class or the config map object. It figures out whatever the current value is, provisions with that. And then you have another controller that's monitoring that config map for changes. If there are any changes to that config map, it will dynamically, after the provisioning process, go in and change the IOPS or whatever.
That's true, but then you're assuming if, let's just say you kept the one config map per storage class, you're now assuming that all PVCs that then need to be updated, not just the user that
Right.
wants
So
higher performance.
that's where I'm saying that we want to make this approach very similar to secrets, where it could be one config map per storage class, or it could be one config map per volume if you want. Or you could even do something weird and kind of like a subset where you have
per namespace.
Or per namespace, right? Or what KK was kind of asking for, which is like, let me have 3 different options, low, medium, high.
Yeah.
So you could say, you know, I'll expose a config map to the user to select between those 3, but what low, medium, and high are defined in a hidden namespace.
I see what you're saying. That makes
So
sense.
you kind of have the granularity from like absolutely one-to-one between storage class and all the volumes, or completely dependent, changeable per volume, or something in the middle where you could have like a predefined set that you pick from.
So far in the proposal, they mentioned like throughput. They are pretty like a kind of standard performance metrics. Is there any other kind of metrics considered? So I'm just thinking if they are very standard across all different kinds of storage, is it beneficial for the whole community? Like we can have a standard API to represent them instead of each vendor have their own and also have implement their own controller.
Yeah, I was about to say that. In fact, like changing the storage SLA on the fly seems like a generic requirement to me. A lot of storage vendors I have worked with, they actually support this. Like having an ability to dynamically change the storage class, or maybe something in config map, having a CSI extensions to update the volume. That seems generic to me.
I mean, we can start with kind of storage vendor specific implementations here with this idea of this config map and controller. And then if it becomes viable, you know, we can consider pulling it back into the core. And if we pull it into the core, you know, we can extend CSI to have a modify IOPS call or something like that. And but that's going to be a larger project. I think it'll require a lot more changes and take a lot longer to get out. But it would be a lot more useful if we already had a couple of proof of concepts or implementations that were already working, and that'll allow you to kind of unblock yourself much more quickly, as well as feed into the larger design.
So Sad, I have a POC with this current approach the whole changes, but I understand your concern that it's larger and it's going to take a long time to get it through. The question, one more question about the config map thing is, can we provide something where we have resource quotas as well applicable in that case? How can we you know, tie this up in those aspects as well? Because currently we can say the quotas, but like we need to make it one of those first class resources to make that happen. So is there a way in which we can do this with config map and specify the resource quotas for performance as well?
I don't think you'd be able to tie it into the existing Kubernetes quota system since it's not aware of these resources. But you could imagine, you know, the controller that's implementing these IOPS changes having its own internal kind of quota management.
Got it. So which ensures that if a change happens and it follows some kind of quota management, it can say, hey, this is not possible. Kind of
right.
Thing. Got it. Cool. Yeah.
Okay. Well, we're actually right on time.
Yep.
So I think Yeah, we do have a couple of things. Yeah, I think we're running out of time. We will discuss the rest of them in the next meeting. Thanks everyone. Bye.
Thank you. Take care.
Thank you.